Hi, welcome to the Dynamic Packet Capture introduction video. As you know, Kubernetes workloads are highly dynamic, ephemeral, and are deployed on a distributed and agile infrastructure. Addressing performance hotspots and troubleshooting connectivity issues is challenging. This is where Dynamic Packet Capture helps. Dynamic Packet Capture is a Kubernetes native way to capture packets from a specific pod or collection of pods with specified packet sizes and duration to troubleshoot connectivity issues faster. A command line interface to easily transfer any generated packet capture pick a file distributed across nodes directly to the local machine for analysis with tools like Wireshark. Let me show you how. Let's assume that we have an application having some issues. There are three tiers in such application: a front end called customer, a service called summary, which for instance in our example, we will assume cannot communicate with the database backend. We can see that there are two endpoints for this service, as HTTP traffic coming from our front end is being load balanced to both of them with destination port 80. In a typical scenario, we will need to log in into every specific pod and run, for example, TCP dump. Then we would need to export somehow those captured files by means of SCP or any other method. That would need to be done for every single pod if the traffic is being load balanced, as in this case, because there is no way to know for certain which path it will take unless some traffic engineering is made beforehand. But likely will not be a good idea, as that will change the setup we are troubleshooting anyway. Here we are talking about only two endpoints, but there could be tens of them. Furthermore, it is not always possible to run TCP dump inside the container, as simply the binary could not be there. Alternatively, we could capture at the Kubernetes node level, but for that we will need to identify in which nodes those endpoints are running, then identify the corresponding interface in the host where we must capture the traffic, and similarly use any tool at our hand to copy over those files to us. Calico Cloud incorporates a feature called Dynamic Packet Capture, which is provided as a custom resource definition, so we can use well-known tools and methods as standard YAML files to define what traffic we are interested to capture. Then we can use labels to select the endpoints we are interested in. In this case, we can see the summary application is being selected. We do not need to know the name of the pod where this application is running or in which node it has been scheduled. We can just refer to it based on the Kubernetes label which has been assigned to this tier of the application at the time of deployment. Before starting our capture, let's, for the purpose of this demonstration, make sure there are no other capture files in this directory. Now let's run this capture applying this YAML manifest and verify the resource Cloud Capture, as we named it, has been created. It is important to note that the metadata contains the namespace, so RBAC controls are in place to impose who can capture what. As part of the spec definitions in the manifest, we have the ability to define additional filters if we want to concentrate on specific ports and protocols. To get these captures, we just reference the name we gave to the capture and the namespace. This is done with the Calico utility, which in my lab has been implemented as a plugin, so I will run the kubectl calico command as demonstrated. The captures have been copied to the local directory, as I have not specified any. As there were two endpoints being matched for the label in my packet capture definition, two files have been copied. Now we can use any standard tool to open this pcap file, being TCP dump, Wireshark, or Tshark as shown in this example. Here we can see, after applying our filter, the DNS traffic going to the database server. I hope this quick intro video has given you an idea of how dynamic packet capture can provide you the needed observability. Dynamic packet capture allows you to specify the size of the packet capture in terms of number of packets or time duration. List the protocols and ports to eliminate non-relevant traffic. It enables the Calico cattle command line utility to automatically pick up files from the right pods depending on where workloads are running. It integrates with RBAC controls to ensure that development teams and service owners only have access to the files associated with their pods or namespaces. And it auto-terminates packet captures by specifying the size of the packet capture by number of packets or duration. Try it yourself with the Calico Cloud 14-day free trial.